Hello and welcome back to eTech Video Production. This video is segment 2 of 6 on Cisco Enhanced Interior Gateway Routing Protocol, or EIGRP. And segment 2 is the advanced configuration of EIGRP. We start first by going through different ways that we can enable or configure in EIGRP. But in a production network, enabling EIGRP alone is not yet complete. What about things like default route, summarization, or authentication? We will go over some of the fine-tuning of EIGRP that needed in a production environment. Then next I'll share with you my best engineering practices when implement EIGRP. And finally, we'll go over is EIGRP our choice for interior or internal gateway routing protocol. I do have a timeline in the description below so you can skip forward or backward to the section that interests you. And if you're ready, let's dive in. We'll begin by reviewing the topology of the lab that will be used throughout this video segment. In this topology, I have 6 devices currently running EIGRP under the Autonomous System 10. Starting with the core switch, which is a layer 3 switch with IP routing enabled. And upstream of the core switch is router 0, where it is connecting with router 1 and router 2 through router 3 in a partial mesh. Then router 3 is connecting with the firewall, where it has full connectivity to the internet. Behind the core switch is 4 VLANs on the 172.16/24 subnet. On gigabit 03 of every router is a PC to simulate the LAN on 192.168 followed by the router number .0/24 subnet. Let's start off with ways that you can enable EIGRP. Let's do a quick review down here. Enable EIGRP with the command router EIGRP, then the autonomous system number. The next command is network followed by a network number. EIGRP routers will immediately look at all the interface, and any interface that fall under this network number here. First, the network will be participate in EIGRP, and second, EIGRP will immediately send hello trying to establish adjacency. As you can see, enable EIGRP is quite simple, but actually there is 4 different methods you can enable EIGRP. And the first one is network 0000. And this is the most simple way to enable EIGRP, as all interface will fall under this 0.0.0.0. And the second method, one time or another, many of us has used this way. That is the network followed by the classful network ID. With this second method, all you have to focus on is the first octet. If it's a class A, you type that number followed by 000. If it's a class B, you would type the first 2 octet followed by 0.0. And in our LAN case, it begins with 192, that is a class C, therefore 192.168.0.0. Again, these 2 methods are the easiest way or the simplest way to enable EIGRP. However, they do not allow you to be more specific. Here's an example. If you use network 10.0.0.0, router 0 will enable the gigabit 00 network, gigabit 01 network, and gigabit 02 network automatically. What happens if you do not want gigabit 02 to participate in EIGRP? These 2 methods will not allow you to be that specific. And this is where method number 3 comes into play. In method number 3, you will use the network ID of each interface, followed by the network mask, but in EIGRP, you have to use wildcard mask or inverse mask. Let's use the LAN network for an example again. You would type 192 168.0.0 followed by 0.0.0.255. Again, the third methods allow you to be more specific. However, methods number 4, you cannot be more specific than this. In the fourth method, you're actually using the IP address of an interface followed by 0.0.0, which is a wildcard mask of a /32, which means match all 32 bits. And this is my favorite method because I only have to focus on the actual IP of an interface, and I do not have to spend time calculate inverse mask or wildcard mask. Enough talking. Let's go enable EIGRP on router 0 using these 4 methods. I have console into router 0, so first let's remove all current EIGRP configuration by no router EIGRP 10. Let's enable EIGRP using the first way by router EIGRP 10 followed by net 0.0.0. And we should have 3 neighbors. There it is. Let's see the routing protocol. You show IP protocol. And we can see all networks. Let's do the second one. Remove EIGRP. Re-enable EIGRP. Now we have to be a little bit more specific on the network ID of a class 4 network. The first one is the LAN, so net 192.168.0.0. And the second, since it begins with a class A, all I have to do is net 10.0.0.0. And I have all 3 neighbors. Without a wildcard mask, EIGRP will automatically summarize the network ID. Let me show you that with an example. I will type in the network ID on the gigabit 01, which is 10.00.4. Now let's take a look at the running configuration. Section EIGRP. And you can see the 10.00.8 is summarized back into the 10.000. Let's take a look at the routing protocol. And it only shows the 2 class 4 network. Let's go with the third ways. Start by remove EIGRP. Then re-enable EIGRP. Now I have to type in every single specific network followed by the inverse mask. We'll start with the LAN. Since this is a /24, so that is 0.0.255. Next is the gigabit 00. And we have neighbor with the core switch. Here we can see 10.0.0.1 on our interface gigabit 00. Now let's enable on gigabit 01. 4 followed by 0.0.3. And we have neighbor with router 1. Then the last one 10.0.0.8. And we have neighbor with router 2. Let's take a look at the routing protocol. That's a wrong command. We show IP protocol. I think I have a little bit too much wine with my wife this evening. So you can see here the 10.0.0./30, 10.0.0.4/30, 10.0.8/30, where the 192.168.0.0/24 EIGRP understand that is a classful network, so it did not have the subnet mask in here. Let's take a look at the run-in config. Section EIGRP, and you can see it have the inverse mask for the 10 network, where the 192.168.0.0 no inverse mask. And last, let's remove EIGRP first. Then re-enable EIGRP. I will show you how I enable EIGRP. I would like to show you how I enable EIGRP. Once in the routing protocol, I would type do show IP interface brief. Here I will look at if I want to enable gigabit 00, this is the actual IP address, so I would type in net 10.00.2, which is the actual IP, followed by 0000, match all 32 bits. And now I have the core, followed by net 10.00.5 with 000, and I have a neighbor with router 1. Now you can see why the fourth way is my favorite. It allows me to be specific. I don't have to worry about fat finger, a network ID, and I don't have to spend time figuring out what is the wildcard mask or inverse mask. Let's reset our configuration back into the first way of enable EIGRP. We start with remove EIGRP, re-enable it. Now net 0000, and I should have all 3 neighbors. What happens if you walk in as a consultant and the company do not want to participate EIGRP on gigabit 02 and their network is configured this way, or even the way number 2 here with the network ID with no inverse mask? How do you prevent router 0 from sending EIGRP hello out of gigabit 02? This is where passive interface comes to play. Next is passive interface. Under EIGRP configuration, you can use the command passive-interface followed by the interface. What that does is telling EIGRP do not send hello out of that interface, where it will terminate any current EIGRP neighbor or future neighbor. Let's console to router 0 and enable passive interface on gigabit 02 to see what happened with the relationship with router 2. We start by capture the gigabit 02 on router 2 and see what is going on there. And let's just filter EIGRP only here. And you can see hello coming from router 0, which is 10.00.9, and from 10.00.10, which is router 2. Here under router 0, we'll go to router EIGRP 10, followed by passive interface gigabit 0/2. It will immediately lose a neighbor 10.00.10 as interface is passive. Let's take a look at router 2. It also received a neighbor termination. Passive interface will send a goodbye to that neighbor, telling it I am down, so don't go look for me. Back into the capture on router 0 on gigabit 02. Now you can see it only receiving hello from router 2 and not sending any out. Let's go back to router 0 and see the protocol. And we can see passive interface for gigabit 02. There's another way to enable passive interface. Let's remove that command, followed by passive interface default. And we should lose 3 neighbor. The passive interface default will tell an EIGRP router, do not send hello out of any interface that is currently speaking EIGRP. Let's go back to router 0 here and followed by no passive interface gigabit 0/0. That will allow hello out of gigabit 02 as we have a new neighbor, then followed by gigabit 01, and we should have neighbor with router 1. Now let's take a look at the protocol, and we can see gigabit 02 is passive. Also gigabit 03 is passive as well. But here's a question for you. Will network 192.168.0.0 be playing EIGRP with the passive interface gigabit 02? The answer is actually yes. Let's take a look at the running configuration for EIGRP on router 0. Under router EIGRP 0, when you type a network command, EIGRP do 2 things. First, that network will participate in EIGRP. Second, I will send hello out of that interface to establish any neighbor. Here, this passive interface default telling not to send out hello, but that network will still be participate under EIGRP. Let's console to the core switch. And let's see if it see the 192.168.0.0. And you can see here 192.168.0.0. A good place to use the passive interface default is actually here on the core switch. So let's enable that. And passive interface default, followed by no passive interface gigabit 0/0.2 router 0. With this command, the core switch will send hello and establish adjacency with router 0 only, and will not send out hello on all its LAN interface unnecessary. Let's double check that on router 0. Do show IP route EIGRP. And we can see all 172 network is here. This output here bring up another interesting subject. As you know, the smaller your routing table is, the faster the router can make a decision. Here in our topology, all the 172.16 network belong to the LAN behind the core switch. Somehow, if we can reduce these 4 entries down to a network, for example, 172.16.0.0/22, that will cover all the LAN's network and our routing table will be much smaller. That is our next subject, IP summary. And next on our list is IP summarization. Here I am on router 0 console, so we begin with show IP route EIGRP. And here's the list of all the routes learned from EIGRP neighbor. We'll be focused on the 172.16 networks, which is all the VLAN behind the core switch. If router 0 receive a packet that have a destination of 172.16.3.100, router 0 have to look at this routing table and find the matching entries. I'm not this guy, 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 I'm not this guy. Oh, I found it right there. But this is a small routing table. If it's a really big routing table, and this particular 3.0 network is on the bottom of its list, it could take some time. But here's an interesting, all 172.16 are destined for the same address of the core switch. Would it be nice if the core switch only sent one entry out, that is 172.16.0.0/22? This network right here will represent all the 4 VLANs in the back. Now router 0 can have a smaller routing table and can make quicker decisions to reach this 3.100. And that is what IP summarization is all about. Let's clean this up. Summarization, also called route aggregation or supernetting. Its purpose can reduce the number of routes that the router must maintain because it's a method of represent a series of number of networks in a single summary address. Some of the advantages are saving memory because there's less route to maintain in the routing table. Next is save CPU resource and make quicker decisions due to this have to evaluate packets against fewer entries in the routing table. And last I have listed here is topology stability. In a very large network, when a flapping interface occurs, for example, if gigabit 1/0 here on the core switch go up and down, all routers in autonomous system 10 have to reconverge and compute for that lost network. Once they finish with that, the interface go back up. Now they all have to reconverge again. But if summarization is turned on the core switch, if any change in the back end, the core switch still sends a summarization, as all upstream routers do not have to go through that conversion, and we have our network stability. Let's go over the command to initiate the route summarization. If we want the core switch to advertise a summary route to router 0, we'll go to the interface gigabit 00, then use the command IP summary address followed by EIGRP autonomous system number 10, then followed by the network ID of the summary address, then its mask. In this case, it would be 172.16.0.0 followed by 255, 255, 252.0. Let's perform this on the core switch and see what happened on router 0. And here we are back in router 0, and it's routing table with 4 entries for 172.16 networks. So let's go to the core switch. Under gigabit 0/0, IP summary address for EIGRP 10 for 172.16.0.0 followed by 255.255.252.0, and we have a new reconversion. Let's go to router 0, show IP route EIGRP, and we only have one entry, and that is the 172.16.0.0/22. And here's another interesting thing. Since the core switch only send one entry to router 0 will take that one single entry and send to all upstream router. Let's go to router 3. Show IP route EIGRP, as it also have only one entry for the 172.16.0.0/22. What about the other way around? Currently right now router 0 is sending to the core switch 4 entries, the 192.168.0.0, 10, 20, and 30. We can do the same thing by summarize on gigabit 00 here, an entry for 192.168.0.0/22. Let's do that from router 0. We'll get in the gigabit 00. Let's take a look at the core switch first. Do show IP route EIGRP. And there's the 4 entries for 192 network. Let's go back, So IP summary address for EIGRP 10, 192.168.0.0, followed by 255.252.0. And there goes the reconversion. Let's go to the core. Now there's only one entry for 192/22. And this is one thing about EIGRP that I love. You can just perform IP summary on any interface to any neighbors. While other routing protocols such as OSPF, the only two places you can perform a summary address, and that is on the ABR area border router and the ASBR autonomous system border router. More on that on the OSPF video segments. While we're on the summarization subject, since the firewall is playing EIGRP with router 3, what happens if it can send a summary address of 0.0.0/0? That is a default route. And that is our next subject, how to inject a default route to an EIGRP autonomous system. Next on our list is how to inject a default route into an EIGRP autonomous system. Here I will show you two ways to achieve that. First is IP summary address. The firewall is currently playing EIGRP with router 3 on gigabit 00, so we can go to gigabit 00 on the firewall and do an IP summary address for autonomous system 10 with a network ID of 000 and a mask of 00. Before we get started, let's take a look at router 3 routing table first. Show IP route. And it does not have a default route, as no gateway of last resort. Let's go to the firewall. And under gigabit 0/0, IP summary address for EIGRP 10 for network 000 followed by 000. Any IP, any mask. And we have conversion there. Let's go to router 3. Show IP route. Now we have a default route. D for I learned that from EIGRP. The asterisk, candidate for default route. Anything I don't know, I'll send to 10.0.0.22. Let's verify that by go to PC1 and ping 8.8.8, and we have reply. The next way of injecting a default route is the use of redistribution command. Redistribution allows any router running multiple routing protocols can take all networks from one routing protocol and inject to another and vice versa. So let's go to the firewall and see what routing protocols is currently running. First, I'd like to remove the IP summary address. No, IP summary address. There's the conversion there. Let's log into router 3. Ensure that it lost the default route. And no more default route. And back to the firewall here. Do show IP route. And you can see here there is a static route on the firewall. Anything it does not know, send it out to gigabit 01. Let's take a look at the running config for that static route. Do show run section IP route. And there it is, a static route. Anything I don't know, send out a gigabit 01. So we like to take this static route and inject to EIGRP. So we need to get to EIGRP routing protocol first by router EIGRP 10. Then the command redistribution. And you can see here any routing protocol, BGP, connected, other EIGRP autonomous system, ISIS, There is the OSPF, RIP. Here is the static. So redistribute static. And we're done. Let's go back to router 3. Show IP route. And now we have a gateway of last resort is .22 for any network. And here is our entry in the routing table. Let's examine these letters right here. The first is letter D. That's how I learned it from EIGRP. Next is the asterisk, candidate for default route, followed by EX, EIGRP external. That network comes from another routing protocol and has been injected into my autonomous system. I have just demonstrated how to inject the default routes to EIGRP autonomous system using IP summary address and redistribution, and you can see it's quite simple. But both of those injections came from the firewall where it is connected to an untrusted network. So before sending and receiving routing information update from the firewall, should router 3 verify that is actually our firewall? And that leading to our next subject, EIGRP Authentication. Let's get started by review the commands necessary to turn on authentication. At the global configuration mode, you start first by create a key change with the command key change followed by a name. This name is locally significant, however that is the name that you apply on the interface. Then underneath the key change, you want to create a key followed by a number. Unlike the key change name, which is locally significant, the key number here must match the key number of the authentication device. Then underneath that key number, the key string followed by a unique value. Once the key change has been created, you go to the interface facing the authentication device, then turn on authentication with the command IP authentication mode, EIGRP, then autonomous system number, then MD5 as the hashing algorithm. EIGRP will hash this unique key string value with MD5 and send to each other. If they match, they will be authenticated. You're wondering why choosing MD5 as a hashing algorithm? Well, this is classic mode and that's the only choice you have. Under the name mode EIGRP, you can use SHA for a stronger hashing algorithm. Then the final step, IP authentication key change for EIGRP, then autonomous system number, followed by the key change name. And that is pretty much it for EIGRP authentication process. Many moons ago, a customer wanted a different key string value for each authentication device. While configuring EIGRP authentication, I always wonder, can I create just a single key change with multiple key and each key have a different key string value, then apply that same key change to all interface? Let me go through that process with you. On router 3 here, we're going to have a key change with two different keys. Key 1, a string value of 123. Key 2, a string value of 456. Where the firewall only have key 1 with a value of 123. And R1 only have key 2 with a value of 456. And this is the problem that I run into. When EIGRP performs its authentication, it always uses the first key available on its list. So when the process authentication between the firewall and router 3, the first key on both devices is key 1 with a matching key string value, so their authentication process is all good. However, between router 1 and router 3, R3 will send key 1 to router 1, where router 1 do not have key 1, and the authentication failed completely. So if you want a different key string for every single authentication device, I recommend a different key change for each one of them. Now, with the basic understanding of EIGRP authentication, let's enable authentication between the firewall and router 3. Here in router 3, let's go to the global configuration. Oh, hang on. There is the discrepancy here. On step 3 of the global configuration, between the key and the string, there should be a hyphen. That's my bad. Actually, I did that on purpose to see any one of you caught that. So let's get back to router 3. Let's start with create a key change and give it a name. We'll call it FW-auth, followed by the key, and those are your choice. So we do key 1 with a key-string. Pick a word. So Cisco 123, and we have our key change. Let's go to gigabit 00. Enable EIGRP authentication with IP authentication mode EIGRP 10, and MD5 is our only choice. So MD5, we should lose adjacency. And the last command, IP authentication for key change, EIGRP 10, and the name of our key change, FW-auth. And we're done on router 3. Let's go to the firewall. Create the key change. Remember, this is locally significant, so R3 auth key, and this key must match the other number as well as the key string. Next is interface gigabit 0/0 IP authentication mode for EIGRP 10. MD5 to turn it on, followed by IP authentication key change for EIGRP 10 R3-auth, and we have neighbor came up. I want to do a debug on the firewall and see that authentication process. Let's stop the debug. And this is what I want to show you. EIGRP receive packet with MD5 authentication with key ID of 1. So you can see the EIGRP authentication process is not too bad. Let's head over to our final lab of this video segment, the EIGRP Stub. Before we dive too deep into EIGRP Stub, let's go through the operation of an EIGRP router when it loses a path to a remote network. Let's focus on router 0. Currently, router 0 only have one path to the core switch for all the 172.16 network. It also load balances via router 1 and router 2 to router 3 for the 3.0 network. But router 0 only have one path to router 1 for the 1.0 network and one path via router 2 for 192.168 2.0 network. In case if you're wondering why router 0 doesn't use router 1 down to router 3 then back down to router 2 to go to 192.168 2.0, or vice versa, down to router 2 up to router 3 up to router 1 to get to 192.168 1.0, please watch our video segment 1 on the fundamental of EIGRP as we discuss the building of topology table for path selection of a successor and feasible successor. Let's clean this up. Somehow during normal operation, the path between router 0 and router 1 just went down. We'll be focused on 192.168.1.0 as router 0 will lose a path to this network. Router 0 will immediately look in its topology table and found that it does not have a feasible successor or a backup path to the 1.0 network. Router 0 will then go active for the 192.168 network, then look back in the neighbor table and found it had the core switch and router 2 left. It will immediately send out a lost route query to those neighbors, asking them, do you have another path to that remote network? Since router 2 does have a path to the 192.168.1 network via router 3, it will reply with a route information update for 192.168.1.0, where in the core switch, it will go active for that network, but it doesn't have a path, so it cannot reply. Router 0 could possibly go to a phase called stuck in active due to did not get a reply back from the core switch, and it will take some time before router 0 go back to normal operation. All this could be avoided if we configure the core switch as an EIGRP stub. By definition, a stub router is an edge router or a router that cannot be used as a transient router. In our case, the core switch is the only one that fit that category. If we configure the core switch as an EIGRP stub, the core switch will notify router 0 I am a stub, so if you lose a network, do not send me this unnecessary lost route query because I am an EIGRP stub. Let's go configure the core switch as an EIGRP stub. Let's start by reviewing the running configuration for EIGRP. And that is a basic configuration for EIGRP there. Let's go to the global configuration and under EIGRP config. And the command is EIGRP Stub. Let's take a look at some of the choices we have here. If I hit enter right now, while receiving routing information update from router 0, the core switch will advertise all connected network plus any summary routes that it learned. If I type the word connected, it will only advertise connected route, in this case all the 172.16 networks. If I use link map, it allows me to filter which route I want to advertise via a prefix list. If I choose receive only, it will not advertise any routes. The redistribute allows us to advertise route via redistribution from other routing protocol, while static only advertise static route, but you still have to send it via redistribution. And finally, summary only advertise summary routes. You also can mix match this, such as summary here, and connected, static, and so on. I'm going to choose just summary route and connected. There is neighbor conversion there, and letting router 0 know I am a stub and do not send me lost route query. And this concluded all the labs for this video segment. Let's go review what we have covered so far. Let's quickly review what we did so far. We went through 4 different ways to enable EIGRP. From the least specific, by using the command network 0.0.0.0, which enable all networks for EIGRP, to using the actual IP address of an interface for the most specific. Then we covered the use of passive interface, While still having that network participate in EIGRP, the passive interface command stops sending hello and preventing EIGRP adjacency. We went over the use of the summarization command to reduce routing table for our EIGRP neighbors, then followed by two different ways to inject a default route into our EIGRP autonomous system. We also turn on the authentication process between two EIGRP routers, and last, with the EIGRP Stub command, we show how it can speed up the EIGRP conversion and not sending out unnecessary lost route query during a lost route. Over the years as a consultant, I've created my own personal engineering best practices when implement EIGRP. These engineering best practices are mine, not Cisco or any other CCIE out there, and I would like to share them with you. First is when enable EIGRP. Always use the actual IP address of an interface. By doing that, it accomplishes two things. First, no mistake of fat fingering of a wildcard mask, and second, from a security perspective, only that interface and that interface networks for EIGRP. Second is where to authenticate. If you ask any security expert, most would say be careful as too much security can hinder the operation performance. For me, at least at the WAN connection or to firewall routers, as on the other side is an untrusted network. Next is summarization. It is the best way to reduce routing table, but be careful as it can alter path because it's not specific. And on any edge device or non-transient device, EIGRP Stub can help speed up the conversion as well as preventing sending out unnecessary lost route queries. IP bandwidth %. This command is probably not useful these days as bandwidth are much faster, but back in the old day, where bandwidth are still in the kilobit per second, by default EIGRP can take up to 50% of your bandwidth during routing information updates, and this command can reduce that. And last is graceful shutdown. If you need to shut down an EIGRP router for maintenance, don't just turn it off, as you can cause a major network reconversion, as all routers will go active for those lost networks. Save your current running configuration first, then these are the ways of graceful shutdown. No router EIGRP followed by an autonomous system, passive interface default, manually change the metric weights or the K value there, or the last one, which I don't quite recommend, is clear EIGRP neighbor. They will terminate, but they will establish neighbor relationship right back. In name mode EIGRP, you can use the shutdown command. All these methods will send a peer termination where the parameters of all K values are set to 255, causing a K value mismatch to the neighbor, then end their neighbor relationship. I have a Wireshark capture of a termination package, so let's go over them quickly. Here's the message from 10.00.5. As you can see, the peer termination parameters right here, and the K values are all 255. Should EIGRP be your choice for internal or interior gateway routing protocol? Let's start with the pros of EIGRP. First is the simple configuration, as you can just use the command network 0.0.0 to enable all networks, or just simply use the IP address of an interface to be more specific. Second, unlike any other routing protocol, by default, EIGRP can have a backup path, or in their terminology, feasible successor, ready in the topology table. When loss of a primary path, EIGRP routers simply just copy the feasible successor to the routing table and continue to route. Next is the summarization. This is one of my favorite about EIGRP, its capability to perform summarize at any interface where other protocol, with the exception for BGP of course, you have to jump through hoops to do that. Take OSPF for example. You can only summarize on the Area Border Router or ABR or at the ASBR, Autonomous System Border Router. And last on my list of the pros, unequal cost load balancing. In network, load balancing is the capability of a router to distribute its load over multiple paths to a remote network. However, to load balance, those paths must have the same metrics. With the use of variance command, EIGRP is the only routing protocol that you can do load balancing on 4 by default and up to 6 unequal metric paths. More on the variance in the deep dive of EIGRP video segment. Now the cons, only Cisco networking devices. Unless all of your layer 3 networking devices are Cisco and you implement the N+1 redundancy, you just can't run to Best Buy or Fry's Electronic to buy a Cisco device when the device goes down on a Sunday afternoon. For those who don't know what N+1 is having an extra device for every device platform. Let's get back to the original question, should EIGRP be our choice for IGP? Well, maybe yes if you are in a flat network, or maybe implement EIGRP at the distribution layer of the old and outdated 3 tiers networking architect. EIGRP should work and works fine. And with the short list of the pros listed here, I cannot argue with anyone who wants to choose EIGRP as their IGP. But for me, when it comes to an IGP choice, intermediate system to intermediate system or ISIS is my preferred choice. ISIS is well known for its stability, scalability, simplicity, and fast convergence. I will upload videos on intermediate system to intermediate system soon, so please subscribe to our video channel and look for those. Thank you so much for watching the advanced configuration of EIGRP. It is segment 2 of 6 of our EIGRP video series. If you like this video, please click the like button below and join our video channel as you look for other EIGRP video segments as well as other technologies. So from all of us here at eTech, stay safe, as we're looking forward to share more information with you on the next video.